Hey, Zoe, what are you doing?
It's a secret, no peeking.
If you're drawing me again, give me a stronger jawline. Last time I looked like two flashlights taped to a gallon of milk.
Have you looked in the mirror lately?
Oh, come on, Zoe, show us. The suspense is killing us. What was that?
Ooh, that was scary.
Your paper just disappeared. Where did it go?
I don't mean to panic, but mystery alert, mystery alert. Paging Dr. Jeff, paging Dr. Jeff, paging Dr.
Did somebody call a doctor?
We don't need a doctor. We need a detective.
Well, you were in luck because I am an expert at solving mysteries of science.
Anyway, where's the paper?
What happened?
Zoe's paper. It just vanished in a ball of fire like some kind of crazy magic trick.
It wasn't a magic trick. I was writing my notes on flash paper and burned it up.
Yeah, but where did it go?
Aha! I think I know the answer to this mystery.
Uh-oh. I think a lesson is coming.
I'm Dr. Jeff Vinegar, and today we'll use the law of conservation of matter to understand where things go when they seem to disappear. We'll see what happens when things change, when they seem to disappear, and when they seem to appear out of thin air. With Dr. Jeff. Welcome to Labracazam, where we make science make sense.
Dr. Jeff, I don't get it. That paper, like at first I could see it and then whoosh, I couldn't. Where did it go?
Well, it had to go somewhere. Why? Because of the law of conservation of matter.
Matter is anything that has weight and takes up space.
Right. And the law of conservation of matter says that the amount of matter stays the same, even when it changes form.
That's confusing. Could we break it down?
You know it. Let's break it down. Let's start with a simple example to understand the law of conservation of matter. First, we'll start by weighing out 25 grams of sugar. Perfect. Next, we'll weigh out 150 grams of water. These scales are set so they don't weigh the weight of their containers. We want just the weight of the sugar and the water. Yes! Now we simply mix the sugar into the water. Here you go.
It looks like the sugar disappeared.
But it just dissolved, right? The sugar's still in there.
Well, what evidence do we have that it's still in there?
We can weigh it. If it weighs 150 grams, then that means the sugar's gone.
And if it weighs 175 grams, it means the sugar's still there.
Let's try it.
175 grams. That's the weight of all the water plus the sugar.
Even though we can't see it.
The sugar is still in there. It didn't disappear. The law of conservation of matter tells us that matter never just vanishes. We can get more evidence that the sugar is still in there by boiling it. This makes the water evaporate more quickly.
As the water evaporates, you can see all the gooey sugar.
So the sugar was in there the whole time, even though we couldn't see it.
Right. Now let's move on to a more challenging example. It's called the fire snake. Don't try this at home. This is a dish of sand, which I am now treating with a highly flammable liquid. Zoe has 20 grams of sugar, and Izzy has 5 grams of baking soda. Now let's mix them together.
This mixture now weighs 25 grams.
Excellent. Let's pour that mixture onto the sand and light it on fire. It looks like a snake just grew out of nothing, but all it was doing was foaming. Burning this mixture creates a lot of carbon dioxide gas. All the bubbles make it appear really big.
So where did all this stuff come from?
Remember, the law of conservation of matter tells us that when matter changes form, it's conserved.
So when you take out all the gas bubbles, it should weigh about the same as the stuff we started with.
Let's try it out.
Be careful, Zoe. Snakes can be very unpredictable.
Again, Bert, it's not actually a snake.
This one weighs a little bit less than 25 grams.
Where'd the rest of the matter go?
Some of the matter became a gas and escaped into the air while it was burning.
So it's the same amount of matter, it just simply changed forms?
Labracazam. We just saw when matter seems to appear. Now let's look at the opposite, when matter seems to disappear. This is a piece of dry ice. It's made of carbon dioxide gas.
Hey, that's the same gas that's in carbonated drinks.
When carbon dioxide gas is squeezed really, really hard, it turns into a solid. My mom had to find out the hard way.
Jeffrey! I ordered this ham from the old country. Look, it's on fire!
That's not smoke bomb, that's carbon dioxide gas made by dry ice getting warmer.
I know smoke when I see it. Curse your ham on fire!
Dry ice changes directly from a solid to a gas without becoming a liquid first. So it's perfect for shipping things like frozen foods. When I put this piece of dry ice on our scale, we can see that it weighs 243 grams.
Actually, now it weighs 242 grams.
Wait, now it's saying 241 grams.
Is it getting lighter?
As you can see, it's turning into a gas. If we waited long enough, the whole chunk of dry ice would turn into a gas. It's almost like it's disappearing.
How can you prove it's turning into a gas?
I can show you. First, let's weigh all of our equipment on the same scale. We're going to use a flask, a balloon, and a few pieces of dry ice.
Altogether, it weighs 152 grams.
Great. Now we just put on the balloon. Now we wait.
The dry ice is getting smaller and smaller, and the gas is inflating the balloon.
That's so cool. But look, the weight isn't changing.
The dry ice is not disappearing. It's turning into a gas. The total weight of the matter is the same, even after it changes form.
Because the matter is conserved.
I get it now. Let's explore some more examples around the house with some real-world science. We can see the law of conservation of matter all around us, even in our own homes. Check this out. I put the candle on the scale to show what happens to its weight when the candle is melting. It looks like it's disappearing, but the fire is turning the wax into water, vapor, and carbon dioxide gas. The candle isn't being destroyed, it's transforming into gas particles you can't see with your naked eye. Yeah, these are raw cinnamon rolls. They're dense, kind of like clay. You wouldn't want to eat these. When we bake them though, it seems that they're getting massive, right? Well, baking them doesn't make more matter. They appear to grow because gas bubbles in the dough blow up like tiny balloons. When we weigh them, the two cinnamon buns weigh about the same, even though one is larger. This is evidence that there is no new matter. You guys go ahead, I'm still examining my results.
Today, we'll explore the law of conservation of matter by making our very own lava lamp. To get started, you're going to need a clear plastic bottle and water, vegetable oil, food coloring, fizzy tablets, a scale, and a balloon. I filled this clear plastic bottle up about a quarter way with water. And now we're going to add food coloring. Next, fill the entire thing up with vegetable oil. Now we're going to weigh the bottle with oil and water, the balloon, and 2 fizzy tablets. It weighs 890 grams. Make sure to remember that. Now, we're going to put the fizzy tablets into the bottle, and it should make carbon dioxide bubbles. I broke these in half so they'll fit inside the bottle. After that, we're going to seal it with the balloon. When the tablets sink into the water, it creates a chemical reaction and makes gas bubbles. The bubbles drag up the color and makes it look like a lava lamp. The tablets seem to have disappeared, but they really just dissolved into the water. 890 grams. See, it still weighs the same because of the law of conservation of matter. Try it yourself.
One last example. Airbags. They protect us in a crash.
Is this from a real car?
Yes, airbags make a lot of gas, but the gas doesn't just appear out of nowhere. It's made in an explosion.
Wait, airbags actually explode? I thought they protected us.
Well, it's a very small explosion, but it creates a lot of gas, which forms a cushion very quickly. Let's count it down. 3, 2, 1.
Whoa!
That just appeared.
If you could weigh the gases made during the explosion, it would weigh exactly the same as the materials in the airbag before the explosion.
So that's like the flash paper. It didn't vanish. It just converted to gas really quickly, like the airbag explosion.
Labracazam.
See, I've been paying attention.
Now, let's review.
Today, we learned that the amount of matter is conserved when a substance changes form.
For example, when sugar is mixed with water, it doesn't vanish, it simply dissolves.
And when something burns up, it doesn't disappear. It simply turns into gases. I'm Izzy.
I'm Zoe.
And I'm Dr. Jeff for Labracazam. Remember, always question, always wonder.